Let me give you another set of examples on evaluating functions. These examples are a little bit more difficult than in the first part of our video. Let's have example 1. We have evaluating a polynomial function f of x equals 7x cubed plus x squared minus 2. And evaluate this function when x is equal to -1. Again, to do that, we simply substitute -1 in this function here. Let's do this. Again, this is equal to f of -1 equals 7. Substituting -1 as the value of x here, we have -1 cube. Okay, that's -1 cube plus -1 squared. So it would be better if we enclose this in the parentheses, and minus 2. And that is equal to 7, -1 cube. -1 times -1 is +1 times -1 is -1 plus -1 squared is +1 minus 2. And we have 7 multiplied by -1 is -7 plus 1 minus 2. Thus, we have f of -1 is equal to -7 plus 1 is -6 minus 2 is -8. Thus, the value of y is -8 when x is -1. This is a polynomial function, and we have evaluated it at x is equal to 1. Let's proceed to another function, which is, again, a piecewise function. Let's evaluate this piecewise function when x is equal to 4. If you are given a piecewise function, you will evaluate the given function using the expression where your given value of x falls under. Okay, in this case, x is 4 and it's greater than or equal to 3. So x is the given value for x is greater than 3. Thus, we'll be using this expression of our piecewise function. Let's do this. We have f of 4 is equal to, using this expression, -3 directly substituting it times, again, x is 4 plus 4, and that is equal to -3 times 4 is -12 plus 4. Thus, the function, our piecewise function, is equal to -12 plus 4 is -8 when x is equal to 4. So again, if we are given a piecewise function, we evaluate it using the expression where the value of x is where the value of x belongs. No? In this case, it belongs in this expression, or in this condition, x is greater than or equal to 3. Thus, we'll be using the expression -3x plus 4. And the resulting value is -8. Now, let's have example number 3. Again, this is another type of function, which is an absolute value function. Let's evaluate this. We have f of -2 is equal to 4 and 4 times the absolute value of we have x here, again substituting x, which is -2 minus 2 plus 1. So here, -2 minus 2 plus 1 minus, okay, wait, minus 7. Let's check it. No? 4, and the absolute value of x is the absolute value of, we have in the parentheses, x is negative 2 minus 2 plus 1 minus 7. We got it right. Then that is equal to, equals, we have, okay, wait, that is equal to 4. Writing it still, we have negative 2 minus 2 using the PEMDAS rule. What's in the grouping symbol or the parenthesis first? Negative 2 minus 2 is negative 4 plus 1 minus 7. Okay, and we have, this is equal to 4. What is negative 4 plus 1? That is equal to negative 3. Before we take the absolute value, we first get the sum of negative 4 and 1, and that is equal to negative 3, then minus 7. Okay? Before we multiply 4 and negative 3, we take first the absolute value of negative 3, and that is 4. Multiply the absolute value of negative 3. Again, when we take the absolute, we always take its positive equivalent. That is 3 minus 7. And we have 4 times 3 is 12 minus 7. And this is equal to, we have now f of negative 2 is equal to 5. Thus, the value of our absolute value function when x is negative 2 is positive 5. Did you get it right? Okay. Now let's have, in our first set of examples, we forgot to add this kind of function, no? To evaluate this kind of function, which is a rational function. A rational function is a function which is the ratio between two polynomial functions. Now let's evaluate this rational function when x is equal to 7. This is a rational function. We will be using the same process, which is we will substitute the given value of x in our function and solve to determine its value. And to do that, we have f of 7 is equal to, substituting in our equation or in our rational function, x is again 7 minus 7 over, what is x again? 7 plus 5. And this is equal to, let's continue this. What is 7 minus 7? Is 0. And 0 over 12, 7 plus 7 is equal to 12. Thus, this is equal to 0 divided by 12 is equal to 0. See, 0 divided by any number is 0. Thus, the value of this rational function, f of x equals x minus 7 all over x plus 5 when x is 7 is 0. And let's have another example of evaluating rational functions. In this case, we have f of x is equal to 2x squared minus 5x plus 3 all over x minus 1 when x is equal to 3. We will be doing the same process again. That is, f of 3 is equal to, see, we have 2. Substituting in our formula, in our equation rather, we have x squared, that is x is 3. Then we have 3 squared minus 5 multiplied by 3 plus 3 all over x again is 3 minus 1. So x plus 1 is 3 minus 1, and that is equal to, let's continue this. Let's just have one line. Okay, then we have 2 multiplied by 3 squared is equal to 9 minus 5 times 3 is 15 and plus 3 all over 3 minus 1 is 2. Let's continue this. We have 2 times 9 is equal to 18 minus 15 plus 3 all over 2 And we have 15 minus 18, it's 18 minus 15 is 3, plus 3 is equal to 6. 6 over 2. And that is equal to 3. So again, when we evaluate this kind of function, this is a rational function, we will do the same process, which is we will substitute the specified value of x in our function and resolve to get its y value. And that is, in this case, when we substitute x, 3 as 3, no, in our function, that is 2. Let's just have a short review, no. 2, 3 squared minus 5 times 3 plus 3 all over 3 minus 1 equals 2 times 3 squared is 9 minus 15 because 5 times 3 is 15 plus 3 all over 2. 3 minus 1 is 2 is equal to 18. 2 times 9 is 18 minus 15 plus 3 all over 2. 18 minus 15 is 3 plus 3 is 6 over 2, and that is equal to 3. This is evaluating functions.